Hi, sir.
Okay. So, okay, first, this is our result. And for the damping, when we adjust to the non-value, the comparison, you can see the amplitude of the wave is the highest when we adjust the damping to the none, and the wave is moving faster compared to the other, which is moderate. And the moderate one is the wave is slower because we adjust it and it lost little amplitude. And but the wave is moving also slower, but the faster. The wave is moving slower than the first. And for the others, the next slide, down the last one, the amplitude is the lowest compared to the other two, and the wave is moving slowest compared with also with other two conditions. If you adjust the tension, as you can see, if the tension is low, the amplitude is the highest, and the speed is slowest compared to the other, which is moderate and high. You can see at the high, the amplitude of the wave is the lowest, and the speed of the wave is the fastest. Okay.
Okay, so now I'm going to explain about the end condition. So, as you can see, when we are using fixed end, the phase, I mean the wave when it encounters a fixed end, for instance, it comes back upside down. That means when you go it like this, but they will go different way when you come back to the from the fixed ends. But for no end, when a wave encounters a free end, it comes back to the same way it went out. That means when you go up, when come back, it will go up. So for the next part, we identify the characteristic of waves that are variable and what are their effects. So one of the characteristic of wave that's variable is the damping. So as you can see just now, when damping increase, the amplitude of the wave and will produce a faster wave. And in the other hand, higher damping will reduce the amplitude of the wave and produce a slower wave. So how about tension? So tension is one of the characteristic will bring effect to the wave as well. So higher tension will produce faster wave, while slower tension will produce slower wave. So besides that, by increasing the tension, the amplitude of the wave will be decreased, while by decreasing the tension, the amplitude of the wave will be increased. So besides that, one of the effect characteristic will affect the wave is amplitude. So high amplitude, when we put for the input, then a higher amplitude of wave will be produced. Low amplitude will produce a low amplitude of wave. So last but not least, the end condition are one of the characteristics that will affect the wave when wave is produced at a fixed end. So just now we say when we produce a wave at a fixed end, the return wave will come back upside down. But when we travel a wave in a no end, the return wave will come back the same way it went out. So show how a wave travel indefinitely. So basically, any mechanical wave in this world will not travel indefinitely when it gives all up of its energy to the medium and disappear. So that means when it use up all the energy, it will disappear, the wave. So the only wave that can travel indefinitely is the electromagnetic wave, but only in one condition. That means in vacuum or a space empty of matter. So it does not lose its energy in a vacuum or a space empty of matter, which means it can be traveled indefinitely or forever. So for these questions, calculate and demonstrate a standing wave. Basically, a standing wave actually is a wave that is a combination of two waves moving in opposite directions, each having the same amplitude and frequency. As we can see, they are moving opposite direction, but they have same amplitude and same frequency. Then they will combine together. That means this is a standing wave. So for the calculation part, actually we did a example, but I don't know how to calculate, but we did an example. This is a simple example. So can you relate this experiment with any real world experience? So can you elaborate this? So in real world experience, a standing wave real life is when we plucking a guitar. So when we plug a guitar, the strings will emit a particular sound frequency depending on the string length and how taut or dense the string is. So the plucking string notes is thus because only certain frequency of stationary waves are able to form on that string under those conditions. Any vibration that aren't the right frequency to make standing waves quickly cancel themselves out, and so is the standing wave frequency that we actually hear. So for the last question, can you explain the phenomena called resonance? So basically, in real world example, resonance can be explained when one object vibrates at the same natural frequency of a second object versus a second object into vibration motion. So I will give you madam an example. So the example is a pendulum. So when a pendulum is pushed and will move back and forth, so if the frequency of pushes of pendulum is close to the natural frequency, the motion and the pushes will remain in step. Therefore, resonance happen. So that's all for us. Basically, for the procedure part, actually, for the procedure part for procedure one, actually, I just set fixed frequency, fixed amplitude, and fixed tension. But I just adjust the value of the damping. So as we can see the difference of the wave for the procedure two, we fix the damping, we fix the frequency, fix the amplitude, but we change the value of the tension as we can. Then we will record down the results or as instructed and include image just as evidences. So for the last procedure, actually we just fix the types of the end conditions. So we fix it no end and fix end. So we'll compare both end conditions and see the waveform of the wave. So that's all for us. Thank you.
Okay, thank you.